So, hello everyone. We have the pleasure to have with us Miss Dr. Muslim Kotob, who will present us a conference about 5G. The conference is entitled Beyond 5G Security in a Nutshell, Basics, Architecture, Challenge, Opportunities, Use Case, and Business Scenario. Dr. Muslim Kotob is a principal solution architect at Vodafone with a lead design and business development role and end-to-end responsibility in enterprise business line. He worked also on driving innovation and standardization architecture in the area of software-defined network and virtualization, autonomics, ceiling, and security in beyond 5G in IoT. He is an IPv6 forum for law and delegate with lead role in various CDO, including ETC, TM Forum, ITUT, and EEE. We have the honor to have him with us today, and let's have a good seminar with Professor Kotob.
Thank you very much, Dr. Skik, and pleasure to be here. I will have the presentation while seated to face the camera better, and when you have any questions, please note which slide you have any question on. After we're done in the discussion, you can ask me anything you want, even in French, okay? And yeah, so let's get right into it. Today, it's a pleasure again to be here at CIHbyEsaip, the conference. I'm going to talk about security in beyond 5G, covering, as Dr. Skik said, threats in 5G, challenges that are faced there, architectures that are there to enable security, and some protection mechanisms. On the website, it was shortly titled Les défis de sécurité à l'ère de la 5G. About me, as Dr. Skik said, I'm principal architect at Vodafone, working with enterprises, providing them with 5G solutions. I'm also in different organizations where I drive standardization, like ETSI, where I'm chairman of Autonomic Future Internet, which is doing primarily autonomics and automation of complex systems. I'm also vice chair of a group on testing and the integration technology in ETSI. I'm vice chair on testbed federations in ITU 2020 and beyond. In ITU, they use different terminology than ETSI and 3GPP. They have the IMT 2020-2030. It is ITU 2020 or IMT 2020 is the same as 4G going to 5G, and IMT 2030 is 6G. So it's different, let's say, context that they use as a notation. I also drive many, let's say, activities in other SDOs like IEEE, NGMN, which is Next Generation Mobile Network. NGMN is the SDO which specified the core architecture of 5G end-to-end, including security. Yeah, this is me basically in a nutshell. So today we're going to cover 5G technology as an introduction. Some of you, who of you knows about 5G a little bit? Raise your hand if you know a little bit what is 5G. Okay, we have a few people. I'll give a short introduction so everybody knows what is 5G a little bit, and then we'll dive deeper into, after we talk about architecture objectives, we'll dive deeper into 5G in practice. What are the use cases? What are the applications in industry and also in consumer, in private sector? And then we'll go into the core of the presentation, which is security aspects and 5G. We will talk about threats, we'll talk about challenges, protection mechanisms, and also what is the way forward. So this is the scope of today's presentation. So in this part, I'll be a bit brief, and please note any questions you may have to ask me after I finish presenting. So 5G technology, it is the 5th generation of mobile communications or cellular communications. It is a 3GPP standard specified in release 14, 15, etc. Release 16 also in detail. 5G, it is designed to have a more reliable, so very precise communication. Communication avec très haute précision. And also it is having higher data rates, so higher speeds, 5G, you are also reliable, meaning that you know exactly when you can deliver your data at what time point. And it also enables, let's say, more massive and more flexible architectures there. 5G fulfills what we call the 4A paradigm. So you can have any rate of data. You can choose your speed, how to send your data. You can send data anytime, meaning they're not limited in time scale anywhere. So you are everywhere with IoT, with M2M. And also it's affordable because the technology is becoming cheaper, available to everyone. So that's why the 4A paradigm, what covers 5G. Basically, if you look at this picture, you see that availability, which is also reliability in a way, it's gone up to 99.999. So you have one more 9 behind the comma or the point. It means that the probability of a system failing with 5G, it is 0.001%. So it's a system which like never fails. So you can use 5G to, let's say, steer cars, to run teleoperations, telesurgery. So it's very reliable. It has very high speeds, 10 up to 100 times more speed than 4G. And also you have more let's say, advances in 5G, which are things like, for example, energy efficiency. So you have battery life, which lasts longer. When you use military applications or farming or agriculture, sometimes you throw away sensors which are placed there permanently. They have to have a long battery life. So it's also efficient in that respect. 5G can go up to 90% down in energy consumption compared to other previous technologies. So it's very important. This is the road, all of you know it, how it went from 1G with analog communication for voice to 2G to 3G, which was the UMTS and the higher data rates and the start of basic applications. And we've been all living with 4G for quite some time, or LTE. And now 5G is coming over. I will not go in the details of this historical roadmap for the sake of time, but I will cover what is new in 5G itself, so you can capture that and then focus on the security aspect and zoom into that. So 5G as a technology, first of all, it's a new architecture, which we will see in more and more detail in the presentation. 5G architecture is designed, first of all, to be more flexible, meaning that you can connect any end device to any part of radio. You can choose any function in software in the system. So you have flexibility in your architecture. Architectures in the old days in 3G and 4G were not very flexible. You had circuit switched and packet switched. You had a clear path how to build the core or transport. You had only one vendor. Vendor is like Ericsson, Nokia, who is providing a certain, let's say, segment of the network. And today you have flexibility in there. You can mix multiple vendors. You can combine things the way that you want. Also, 5G also introduces new frequency bands. So the frequency of communication is an important aspect. You have higher frequency bands. When you increase the frequency, like when you listen to the radio, you have a frequency that you tune to listen to some stations. Frequency, if it goes up, data rate goes up. So the speed of your connection goes up, but also the cell becomes smaller. So if you have a high frequency, like, for example, 7 or 10 gigahertz, you have very high frequency, very high data speed, maybe 1 gig on the wireless, but then your cell will be really, really small. So that's why 5G has a higher frequency operation mode and smaller cells that you have. In 3G, cells were very big. They had a radius of maybe 5 kilometers. And in 5G, cells are getting smaller and smaller with higher frequency. And you have a new concept called network slicing. Slicing is, slice of cake or slice of anything is a piece. So slicing means that in the network, you cut a tunnel of resources to communicate end to end. So if I'm talking, for example, to Alexis, for example, and there are several segments, I have to cut in all the segments resources to have a channel which is dedicated for this communication purpose. So there are 3 main things that are new coming out in 5G. Here you can see that depending on the area, if it's an urban area or industry zone, or if it's a widespread area, you have different frequencies that you use. You have 4G and 5G new radio operate on lower frequencies, like 700 megahertz, for example, but you have large coverage and large cells. Then you can go smaller with medium frequencies, like 1.8 or 2.6 gigahertz. And then you can go even with higher frequencies, but very small cells. Like if you have, let's say, dense urban areas in the city center of like Paris, London, or Bordeaux, whatever, you have small cells with 3.5 gigahertz frequency, what Orange deploys, what we deploys. So small cells with very high capacity, and you have many of them in dense areas, les zones concentrées. Okay. So in 5G, what happens, as we mentioned, that we have higher frequency bands. That is one of the key differences. You have the small cell technology, because to manage a small cell, it's important. And also to manage many cells, important. How to coordinate different small cells that you have. Because if I want to cover, let's say, this table, suppose this table is the half of, for example, Angers, I can cover it with 4 3G cells. Each one has a radius of maybe 5 kilometers. But if I want to cover with 5G cells, I need maybe hundreds of cells with a small radius. So that's why how to manage small cell technology is also important. Beamforming, it is a physical layer thing. How do you connect the different, let's say, beams or signals into a good shape? So you can combine, you can enhance, amplify signals, and then this allows you to have more bandwidth, more speed, and less interference with 5G. And of course, MIMO, multiple inputs, multiple outputs. If you use several physical components, you can have a stronger receptor for input, and you can emit also a more powerful output out of your device. So even mobile devices today, they have MIMO antennas inside your handhelds or cellular phones. When you look at 4G or LTE, it had what we call Evolved Packet Core, or EPC. It's le noyau, the core of the network. And then you have the RAN part, which is the radio access. When 5G started, it only had a new part on the radio. So the first 5G was called NSA, non-standalone. It means not independent, but it was leaning and using the 4G core, but having only new technology in the radio part. Radio part, it means between mobile device and the base station or antenna. This part is the radio. So 5G started with a new radio, but old core of 4G. And then the next generation came in 3GP release 16, which is the 5G standalone. In 5G standalone, the whole core is a pure 5G core. It is based on software and hundreds of microservices, and it enables a lot of new perspectives, and it's a very powerful core. And we will discuss about that a little bit so you can get an idea why a new core that 5G has in standalone is a challenge to cybersecurity, but also a lot of opportunities coming with that. So that we will see in our presentation today. Okay. So maybe we skip this graphical thing here. Just see that in 4G you have, let's say, channeled communication directed towards a specific, let's say, area. And in 5G you have distributed different kinds of small mesh networks, small private networks, and they're all interconnected. So there's a lot of coordination in 5G, and not big clustering like in 4G, but many, many different parts that have to communicate within, intrinsically, and also outside. So there are many standardization groups that work on. So 5G, what is it in its core? It is a specification by 3GPP. Is there a question there? Sorry, I thought you raised your hand. So 3GPP is the third generation partnership project. It is the SDO organization that specifies 5G and also 4G, and it's now specifying 6G. So this is one organization, and their specifications, for example, release 15 or release 16 of 3GPP, they contain all the details. You can download publicly even these specifications and read about 5G technology. It is all specified. Other organizations also are important that work there, like ITU, International Telecommunications Union, is also there. You have also other projects like 5G, PPP. You have NGMN, Next Generation Mobile Networks. NGMN includes all the large operators of the world. So NGMN, you have Orange France, it's a member of NGMN. Vodafone is a member of NGMN, Deutsche Telekom, Verizon. So all operators, tous les opérateurs, they are in NGMN. And NGMN has a white paper. If somebody wants to read, you can contact Dr. Skeek or myself. There's a white paper, like Architecte, specifies the architecture of 5G end-to-end. It's by NGMN. It is the base for designing and working with 5G. Then you have others like GSMA, ETSI, etc. And also you have sometimes national organizations, like in France, it's INFOR, Association Française de Normalisation. They also specify things that you have to comply. So, for example, if you want to operate, let's say, a mobile device or a router, connect to a 5G network, You have to be compliant with the standard, and sometimes there are specifications coming also from national agencies like ANFOR. It's important to know what are all the requirements, tous les conditions, il faut les connaître. Okay. So then we will dive into 5G in practice, what is really, how it looks in real life, what we have there, including industrial use cases, and also some of them in the consumer domain, meaning private users. Okay. So in practice, again, 3GPP specified 3 types of slices, and these 3 types, they form the 3 categories of applications in industrial or even consumer 5G. So we have 3 groups here. One of them is called EMBB, which means enhanced mobile broadband. Broadband means high-speed communication. Mobile, is also field. So high-speed communication on wireless, this is one kind of, this is more for a consumer or for interactive applications. For example, you have high definition, or do you have even 4K video or even 8K video? You have high definition audio. You have also, let's say, network gaming, cloud gaming. This all is EMBB type of application. It has interactive, because video voice are interactive. And also it needs high speed. So a lot of data and interactive communication. So it's not going one way, or it's always going and coming. The other category, it's called MMTC, Massive Machine Type Communication. It means that machine type communication, it is IoT. IoT, Internet of Things. I don't know, in French, Internet des choses, I think. So also IoT is called sometimes machine to machine, M to M. So when machines communicate with each other, it could be a sensor, it could be a wearable device like a watch, it could be any electronic device. Even today you have at home electronics like washing machine, coffee machine, they all have communication capabilities, your heating system. So when a lot of sensors and machines communicate, this is a massive amount of data, massive amount of sensors, of source of data, or of recipients of data. So IoT and M2M is covered by the slice type MMTC. And this applies to use cases like smart city. Like, for example, you go to the metro, the station tracks your member card. You can access the ramp and go into the train. Smart home to control your home heating, automation, monitoring, vigilance, monitoring system. Smart traffic, all the traffic lights, coordinating the traffic. You also have, it's a lot of IoT sensors in the devices. Also, you have what we call VR, AR, virtual reality and augmented reality. I think you all heard about the metaverse. Facebook is called now Meta. So virtual reality and augmented reality, it means that I can have, let's say, a session where I have real people like you in the room, and I can have people virtually, and it feels like they're all in the same place. So I can submerge something into an environment because of the very high quality of connection, the high resolution. It feels like everybody is in the same space. So that's why this also with AR, VR, possible thanks to 5G. And you have finally a very important type of application or slice, which is the ultra-reliable low latency communication, URLLC. Ultra-reliable means it is very precise and never fails. And low latency means it's very fast. So I can communicate within 1 millisecond, 2 milliseconds. So suppose I want to do telesurgery, for example. Somebody is a doctor in US and the patient is in France. So doctor could move around devices or conduct his operation on the patient from remote. You need to have a very, very low delay in the communication and to have very accurate communication. So that's why things like telesurgery, as you can see here. Also, Industry 4.0 is all the industry production, all the factories like, automotive, retail. They all profit from this kind of reliable, they need precise communication. If you have robots running a factory, you need to have very exact communication slots. And also autonomous vehicles, autonomous driving. Not only Tesla, but others are having cars which are steered by networks. You have to have reliable and very accurate communication there. Okay. So this is graphical display of what I just discussed. So you can just enjoy the image for 2 seconds here. And then here you can see on the right side, there is the industry plant. So you have robots which are run by 5G. Of course, 5G works well with AI, in French IA, intelligence artificielle. So AI needs a lot of data. AI is data hungry. So AI to work, you need big amounts of data. 5G can access lots of data and can process them. So that's why AI and 5G, they work well together. And you can automate factories and let robots run complex chains or processes there. You can also apply 5G in agriculture, in many different sectors, logistics, etc. Exactly. Private networks, what you call campus or campus, if you want. An enterprise can run a closed 5G network. So there's, let's say, a factory of Peugeot, for example. They usually have a private 5G network, which is closed network, réseau fermé. And in that network, they have short slices. They have all the communication. And they don't communicate to the outside much, except through a very specific secure channel. So private networks is a very common business model that companies build to communicate securely inside that private network. And this is displayed here as I drew for you here on the slide. Okay. Then you have also global 5G networks with a long slice, meaning that you have an enterprise somewhere, you have an edge cloud, you have a cloud center, and the communication is going all the way from the enterprise outside the private domain through transport network, which could be leased line or fiber, going all the way into edge cloud domain with MEC, multi-access edge computing, and then into the cloud data center. So you can have long slices and you can have short slices like here inside the closed enterprise private network in 5G. Okay. Also, you have something called collaboration federation. You have, let's say, multiple operators like Orange, Vodafone. When they communicate, there's also one mechanism called federation. Federation means that you can share assets, meaning that I'm one operator, for example, and there's another operator here. They can use my resources like a test bed, computing capacity, storage, maybe on the air interface, the spectrum. So I can share my assets with others. So I federate, I pass over under some conditions, some resources, and this way I can increase my span. So you can federate a test bed, you can increase the access of your resources by federating, by accessing them from another one. You need to establish for that a trusted relationship so you can trust each other. And then there is also the issue of payment. How do you, let's say, compensate for federated assets? There's also another aspect which is very much taking place with 5G. Okay. Then we will dive into the beef, as I call it, of the presentation. So 5G security, let's talk about, let's say, architecture and standards. What is the view? So this is a 3GP specification, TS33501. So it classifies the interfaces that need security or the channels into 5 categories. One of them is, of course, you can see on the left side, you have a user and mobile devices. You have also what you call the USIM, universal SIM. You all know, you all use your SIM cards. By the way, if you have IoT or machine to machine, it also uses SIM cards, but they are with disabled voice. So if you take a classical SIM card, you disable the voice, just data transfer, it becomes IoT or machine to machine. So you have here the universal SIM. You have the base stations or eNode B, 3GP radio access technology, and you have non-3GP. For example, Wi-Fi, for example, WiMAX. So you have in 5G the chance to communicate with 3GP technology like 5G itself and others which are compatible. They interoperate, including Wi-Fi as an example. And here you have then your, let's say, your visiting domain. For example, you are roaming, and you have your home domain on the right side, which is the navy blue color. So what are the interfaces that are important and which are impacted by security? From an architectural perspective, you have network access security. So to access a network, there should be security. This is the interface which is almost everywhere. So between mobile device and let's say 3GP base station or not 3GP like Wi-Fi, it's between the radio base stations or antennas and the visited domain, between visited domain and also the home domain, also between any SIM card when it builds the connection to the receiver on the visited domain, etc. Then you have another kind of interface which needs security from an architectural perspective. It is network domain security, not access, but the domain itself. You have 2 domains here, visited domain and home domain. So to access your domain, let's suppose, for example, somebody is roaming in another network. They have to check in another network who you are. They ask your home network, who is this? They say, okay. So this communication between domains, it's called network domain security. To access a domain, you need to be sure. It's also shown here between the two visited and home domain here. You have also user domain security, meaning that if you're a user, you identify yourself with your SIM card, with your PIN, with the IMSI on the SIM card. So this is another interface which needs also to be secured. You also have application domain security, which is here on the upper part of the image, between the user and your application. If it is, let's say, a login password, if it is two-factor authentication. You all know two-factor authentication. When you log into a page, you get on a mobile phone, let's say, some token you need to validate. So authentication on application level, directly between user and application. This is also another important interface to be secured. And you also have what we call SBA, Service-Based Architecture Domain Security. It's very important. I will show you briefly what is SBA. SBA, it is 3GP specification for the software-based core. So when 5G moved to a software-based core, they specified service-based architecture, meaning that these are all these bubbles, or these are functions in software in the 5G core, the new 5G core. And these functions, they are grouped based on different categories. For example, some functions are responsible for signaling. Some of them are responsible for policy. What is the c'est quoi la politique? How to run your network, your sources. Some of them are in the security area. Some of them are like here in the pink domain or the magenta. It's the user and data management. Some of them are for network resource management. So SBA defines all the software functions of the new core of 5G and groups them based on their, let's say, categories. And also it enables end-to-end operation. So I can open a slice or run a function from the core through the transport, edge, all the way to run and to the user. So I can work end-to-end. Exactly. And that's why here I wanted to show you briefly security in the enterprise. It's with enterprise companies or customers. The end-to-end value chain, it has several domains which are shown here in color on the slide. So you have things like edge and MPN, mobile private network, like I showed you before. You have also other domains like the distributed edge cloud, which is after the RAM part. You have the cloud itself with all the hyperscalers, which you all know, like Microsoft with Azure, AWS from Amazon, and Google Cloud. And then you have also on the left side the IT of the enterprises. So security, if you want to secure something, an application is going through all domains, you have to secure all the path through all the domains, and there's a lot of challenge in that aspect here. Okay. If we look briefly at threats in 5G, what are the threats? Cybersecurity, from that aspect, you have identity change or let's say manipulation. So sometimes there is masquerading. Somebody could take an identity which is not the real one and pretend to be, let's say, the user, and then could misuse data. You have also interception of a connection, like tapping. It's easy to intercept a wireless connection. No, a physical wire is harder to intercept, but on the air interface, you can easily intercept. Also, there's a lot of, let's say, malicious ways to easily track or monitor subscribers and users. For example, tracking their location, coordinates, or other things. Also, one very common thing with 5G, it's called IMSI catching. IMSI is your subscriber identifier on the SIM card or on the mobile device, which is unique. So sometimes you can intercept by doing IMSI catching. You can pretend to be, let's say, you can be a fake base station, pretend to be a real one. You can stand in the middle. It is similar to what you studied in cybersecurity, what you know as man-in-the-middle attack. So I'm talking to this part. Somebody comes in between, pretends to be that one. So I'm talking to somebody who is not really that one. And then you capture sensitive data. You impersonate an eNodeB or a base station, and then you are acting on its behalf. There are also threats in the, let's say, privacy area in 5G. So as I told you in the beginning, in 3G, you had very big cells. One cell had a radius of maybe 5 kilometers. In 5G, a cell has a radius of few meters. So if you have a 5G domain somewhere, it's a very small cell. So you can know from the cell what is the ID, who is the owner, what is the location. So it's easier to track and deduce information based on 5G because of smaller cells. And that's why with AI and big data, you can combine things, and you can also, let's say, capture more data that should not be really captured normally. And to mitigate this, the only way is to do privacy by design, meaning that collaboration between stakeholders. So if I'm, let's say, the energy provider, somebody is network provider, somebody is the vendor, somebody is the service provider for end user services, they should collaborate to protect the privacy, because one cannot protect on it on his own. One stakeholder, like the operator, cannot hide or cache the privacy of the user of that 5G network. Other threats in 5G, resource virtualization. All know, the cloud. You all know, who knows what is cloud technology or cloud computing? Do you know what is cloud? Okay, perfect. So we have some people. So in cloud, what you do is that you virtualize a function and you run the function in the cloud. You don't run on your own servers. That's why with more virtualization, you have functions which are distributed, which are placed in the cloud. So it's harder to really secure this application. It's going through a remote location. You don't even know where the cloud is located. Okay. Then you also have one thing, which is resource sharing. So you have, let's say, a physical, resource like a server. On the server, you have virtual resources like, containers, like Docker containers. You all know Docker containers software, or virtual machines, which are running some computing. So when you share resources, you have more exposure to harm, and there is no more boundary between the physical and the virtual application. So this is a security threat which comes along as well. Also, today we have more and more open source. All of you are, let's say, good programmers. You use software to implement things. So with open source software, it's easier to be attacked, the software, because the code is open. You can crack it, and that's why you have to also secure ways to, let's say, avoid this kind of attacks. Also, you have today what we call multi-vendor environment. I don't know if you heard about what we call Open RAN or virtual RAN. RAN is the radio access network. In the old days, you had one operator like Orange, one vendor like, for example, Ericsson. Ericsson provides all the equipment. It's one vendor, one operator. They have the whole network together. Today, Open RAN, you come as Orange or Bouygues Telecom, for example, and you have multiple vendors, Ericsson, Nokia, Huawei. They all provide hardware. They all work together in the environment. So there is a mix of vendors in the environment. It's also a security threat. It's a flexible model, but it introduced more challenges. Other, let's say, threat vectors that we can talk about, which need security improvement. I can briefly touch upon some things. You have in 5G, let's say, user plane integrity protection, meaning that in 3GPP, you have in 4G, in 5G, you have a, let's say, a control plane, which is for by the operator controlling the network. You have user plane where data is communicated. So you are using data communication. It's in the user plane. Network is controlling your sessions. It's in the control plane. So integrity protection of the user plane is something which 5G introduced. It was not available in previous generations, and it's very important. Then you also have things like, let's say, subscriber concealed identifier, which is the SUSI. It is actually one way to avoid this IMS eye catching that I talked before. Okay. You have also in 5G encryption with longer keys. I will not go into details of the keys, but if you had before 128-bit keys, which are, let's say, more easily cracked, today the least key length in 5G is 256 bits, and some of them are going with. We also have with our customers keys that go in length up to 512 or even 1024 bits. So longer keys for stronger encryption. It's harder to crack. And then also network slicing that I briefly touched upon. It also, when you have slices that are tailored for 5G, it's a good aspect, but you need also to secure some slices if they are critical to your application. This is here just the graphical display of the aspect that I mentioned here. With 5G standalone, you have a large, let's say, improvement of what you had before compared to 4G, like the examples that I mentioned to you. Okay. On the air interface, when we talk about security, if you are a CSP, which is communication service provider, CSP means provider which has réseau mobile and réseau fixe, like a big, and MNO is mobile network operator, which is only réseau wireless network. So today they all use 2G and 4G and now also 5G. So in that domain, you need to protect things like identity from manipulation, masquerading, etc. You need to prevent interception or tapping on the wireless connection. You need to track what users are doing to see if there is any suspicious, let's say, pattern there. And you also need to do some configuration in your network if you're an operator to reduce the risk and to do some configuration. For example, you should frequently check if the user which is using the network, if it can re-authenticate itself to check if it's still the right user. You can check patterns if there's any weird or unusual usage in the network or behavior. You can also, let's say, deny connection to devices if the connection is not secure. You can choose if you enable an interface or not, and this kind of things. And then, if you look at it in a graphical form, on the air interface, if it's 2G or 4G or 5G new radio, which is with the same core as 4G, you have older interfaces. They're all specifications by 3GPP. They used to be called, let's say, A52, GA3, or GA2. So GA is GPRS encryption algorithm. A1 is older than A2, A2 older than A3. So these are all evolving to have longer key length and to have more strict checks. So as 5G is going along, it is rejecting all the standards and asking for newer ones which are more secure. This is how it works. Okay. You have also, let's say, cryptographic encryption protection requirements. Sometimes you have to have least key length. Sometimes you have to have, let's say, asymmetrical cryptography, like RSA, for example, not DS, which is symmetrical. So also you sometimes, you all hear about blockchain. And so you have block encryption or trusted chains of security. You can encrypt a certain flow, not only data chunks, but the whole flow as a stream. You can encrypt it also. You have also protection which touches upon storage. So you store something in a protected way. You protect the endpoint for the entry of data, the exit point, and the storage itself. So there's ways what you can protect and what you should protect, etc. And these all have, let's say, criteria that we should look into. 5G standalone, as we mentioned, enables, let's say, tailored security per slice and per subscriber. So you can choose what slice to build through what path to what endpoint, and what is the security required for this slice. If I'm communicating something critical, my slice should be encrypted maybe with 128 bits, 256 bits, etc. So this is also important to note here. I will not go deeply into this, but just to tell you briefly, technologies like Wi-Fi, which is non-3GPP. Wi-Fi is an IEEE standard, IEEE 802.3. No, sorry, IEEE 82.11 is Wi-Fi. 803 is Ethernet. And you have 4G, and you have, let's say, 5G standalone. They all use different mechanisms. So you want to identify your device, for example. In Wi-Fi, use the MAC address. You check what is the MAC address. Is it authorized to access Wi-Fi? You can have a filter or a blocking mechanism. In 5G and 4G, you use IMEI, International Mobile Identification Number, and PI, as it's called in 5G. It's easy to fake a MAC address. So if you can fake a MAC, it's easier to access. That's why 5G is more secure than Wi-Fi. You have also identifiers for security like LDAP, which is a directory for access, and use the IMSI or the SUPI, which I showed before on the slide for 5G. And then you have, let's say, virtual LANs or subnets, and use what we call slices in 5G, and also on different APN. APN is access point name. It's the access point which defines the domain of a network or a small cell in 5G. Okay. Here, I would just briefly mention that with user plane integrity protection that I mentioned before, it allows to mitigate impersonation attacks, meaning that it's harder to pretend that you are somebody and to talk to the user and grab his data because of this. And with the 5G standalone, which is the software-based core, you have also protection on the user plane thanks to UPIP. This was not possible with 5G new radio or with 4G. Okay. So moving along, this is what I mentioned briefly. So old generations of encryption mechanisms, they have been now upgraded to new ones, and systems that reject older ones because of short key or because of weak security. Okay, this is the essence of this slide. Some examples of where you apply security in 5G, you have assuring or monitoring enforcement, meaning that which functions from the 5G standalone core you need to assure that the endpoints are secure. So how do you monitor the session? How do you check integrity of the session? So you need certain functions from the SBA architecture that I showed you. User plane security, you have to connect the session management function, the SMF, and the AMF functions. And on each interface of these two functions, you have, let's say, a security check to see if the connection is proper. The SMF session management is connected to the UPF, which is the user plane function, where your data is going through. Your data, when you communicate, is going on the user plane. Okay. You also have user traffic filtering, meaning that I'm a user communicating. There's a filter on my applications. If I'm using voice or video or chat or data, it checks what is the port that I'm using, what is the pattern, and then you can control the traffic with functions of 5G core, and then ensure that everything is correct, Because, for example, DDoS attacks, you do a lot of, let's say, shooting of packets in a weird pattern to choke the system. So you can check the pattern. For example, voice packets, always voice arrives at a fixed distance. So if I send the voice packet, it's a small packet of maybe 128 bytes. And between every packet of voice is a fixed distance of delay. It's the same delay packet, fixed delay packet. Video has, let's say, larger frames, smaller frames with varying delay, what we call jitter. So that's why when you study the patterns, you can detect what is there. You can detect security threats, and you can act upon that. Okay. Also, 5GP and in 5G standalone, it reduces what we call security edge protection proxy, meaning that you have visited network where you are roaming, you have a home network, and between them there is an interface, which is the edge. So the edge is the la frontière of each domain. So edges. So these two frontiers, they are at that interface. There is a special protection specification by in 5G standalone in release 16 3GPP. It is called SEPP, and it is shown here on this image, so that you can, let's say, protect yourself from different kind of attacks. Okay. This is just an overview. When we have our Vodafone security framework, you can see that there is what we call physical security. So what are the aspects that you have there? Customer environment protection, IoT integration, application security. You have what we call digital security. So you can see system hardening, network segregation, meaning you cut the network into partitions and you secure each one separately. You have also account and asset management, secure and remote operations, etc. You also have regulatory environment, like we talked about AFNOR and all the specifications. So there's regulation governance, which is the green part. And also the cycle of development of security in such a 5G environment, it's called security by design. So you'll be secure by design, meaning that when you design your network from the basis and your IT, you take security into account. You don't add afterwards. From the beginning, you think of security, how to enable the security that you need, okay? And just briefly about, because you all hear already about 6G. So going from 5G to 6G, already 3GP specifying a lot of things about 6G, because the release 15 and 16 of 3GP specify 5G. Release 17 contains some 6G, and release 18 will contain a lot of 6G aspects. 6G compared to 5G, I will briefly maybe use a couple of slides for that, and then we'll move into discussion also with Dr. Skik as well. So the thing is that in 6G, you have not only collective intelligence, but you have intelligence in every aspect, every asset, every player, and they collectively, it's a collection of intelligent entities intelligently coming together. So it's a much more complex environment, cognitive, much more interactive, and you have many more things possible there with 6G. Some of the common, let's say, use cases that you already see, I'm designing some of these things together with partners, which are a little bit going in the direction of 6G. So you have there, let's say, submersion, like I said, with AR, VR, or like the metaverse is working. So you have a virtual, let's say, audience there, real people. You can put them in the same stream, in the same discourse, and it will look like they're all together in the room. So you can virtually be in a place as if you are really there. It requires high bandwidth, low latency, high precision. This is maturing more and more from, let's say, fun into serious use cases. So a company can have meetings across the world as if people are all in the same room. This is maturing with 6G. You have also more integration in 6G with between technologies of 3GP and other ones, like for example satellite or IoT and space. So today, if you need to communicate with satellites from 5G, you need like a gateway adapter in the to modulate. But 6G will enable to shift between satellite, IoT, 6G without noticing any, let's say, cut or any complex things that are needed for that. Also, you have, of course, more mobile private networks, campus enterprises, data sharing, big data with 6G. You have also more open ecosystems, meaning that you can have one or more operators, one or more vendors like Nokia, Ericsson, Huawei, all of these, all communicating in one environment. You don't have anymore one vendor coupled to one operator. And you also have what we call smart edge. Today you have many, let's say, providers. They push all the application to the edge, so you are on the edge. And this is why, for example, if you have, let's say, Netflix, and Netflix has a very fat edge where you do the caching. You know how, for example, when video streaming, how it works. You use a Netflix stream, you click on a video. There is a server or multiple servers with this video. It goes to different, there's many cache points. The data goes in chunks to the cache point. And from the cache point, it is streamed to your device so you can watch your video. So if the cache becomes intelligent and you have more caches than before, it can prefetch, you can get data in advance with intelligence and stream, and it can process. Then you will have like a smart edge here without needing to have, let's say, a lot of server communication. So as the edge becomes more complex, even for streaming, just as an example, this is called smart edge. It's better enabled with 6G because your radio is a strong connection. You don't anymore need other things behind the edge here on this side. Okay. As we go from 5G to 6G, we have, let's say, the default application types that I discussed, the slice types of 3GP, which is enhanced mobile broadband, ultra reliable low latency communication, and massive machine type communication. In beyond 5G, you have, let's say, more evolution of this, like mixing of these slices. In 6G, you have even stronger requirements, even more performing slices. So even lower delay, not 5, but maybe 1 millisecond. You have higher data rates. Device types also are evolving with more sensors integrated. You have also extended reality. You have a lot of, let's say, power in the devices that support 6G. Frequencies also are going up. You can see even here 1 terahertz, which is a scary frequency. You also go up in data rates. So the speed of your connection is going up. Delay is, as I said, going down, even below 1 millisecond with 6G. You also have mobility range. So the speed, even if you're driving in the car and talking on the mobile phone, if you go like 160, okay, in France, you shouldn't go 160, but if you go faster, your connection gets weaker. But 6G can support higher mobility speeds, even airplane speeds like 1,000 kilometers per hour, and you can still have a good connection. Internet of Things, of course, IoT is increasing. It will be Internet of Everything, etc., etc. And of course, security, secrecy, and privacy, it evolves. So as 5G goes to 6G, security also evolves for these new requirements. And just a couple of examples on my last slide here. In 6G, for example, when you look at that, you have even, let's say, higher degree of privacy. So network is so designed that your privacy, your identity is secured. 6G also works on things like, for example, let's say, intermittent connectivity, meaning that you can connect, disconnect, or access anytime that what you want. You don't have to have continuous service that you are booking. You're always able to access anything you want at any time in a flexible way. You have also, of course, higher energy efficiency. You have many things that are coming with 6G. And this all, let's say, pays off as you go along. And with that, I think I finished my slide deck. Thank you very much for the first part. And now we proceed to the subsequent parts.
So thank you very much, Dr. Elkotob Muslim, for this presentation. We have a lot of questions online for you, and we have maybe some question here. So we start by question at the amphi.
Okay.
How 5G can make the battery life longer? Because in the slide 5.
Okay. Let me open the slide. Slide 5, you said?
Yeah.
Okay, let's follow that so we can follow what you're saying. This one? Okay, yes. What was the, can you repeat your question? Please speak a bit louder if you can.
How 5G can make the battery life longer? Because makes the battery life longer.
Okay, yeah. So energy, for example, let's say 5G, it has new mechanisms with MIMO. So the antennas are, there are multiple antennas. Some of them operate on low power, some of them operate on high power. So you can tune the power that your antenna is using. So for example, if you are, let's say, a 5G emitter or radio part on a sensor that you throw in a farm or in a military zone, there is a mechanism which is called wake up on packet, meaning that, like you have, for example, wake up on LAN, you can have a PC connected to Ethernet, and it is in sleep mode. Then you can send the packet, the PC turns on. You can also have, let's say, base stations or sensor or any module that goes into sleep mode. And when you are, let's say, seeing a packet coming, it will go active again. You know, for example, in Sweden, Sweden, they have on the autoroute, on the highways, they have, let's say, illumination lamps, which have sensors. When they detect a motion like a car coming, they illuminate. So if you can go into sleep mode when there is no active communication, and then you can go active when there is detection of a packet, in that case, you can increase battery life. Also, the communication itself, for example, let's say, if you need to transfer, let's say, 1 gigabyte of data, of interface, the vendors like Ericsson, Nokia, Huawei do the hardware. The French Alcatel later became Alcatel-Lucent, and it's now Nokia. You know, so there's also French in today's Nokia, which is one of the main vendors. So Nokia even is working with in its hardware, being more efficient, meaning that if Nokia had, let's say, chipsets for 5G, the chipsets for 5G, they come from different vendors. Some of them are Qualcomm in the US. So the chip mechanisms, let's say,
Excuse me, there is just a problem, I think, in your laptop. We couldn't hear you anymore.
Okay. Oh, sorry. Is it now better?
No. We lost your
Display or
yeah, everything.
oh, okay.
Are not connected to internet anymore, I think.
Oh.
No.
It's connected.
okay. Okay, is it back now?
Yes.
Okay. Okay. So yeah, now next question, please.
Okay. Next question.
Oh, perfect. Great.
So that technology would be deployed in the company, or is it too expensive?
5G technology will be, please can you speak louder a bit?
Deployed in a company, or is it too expensive?
In companies, enterprise?
Company, countryside.
Okay, yeah. Yeah. So 5G you have different modes. For example, if you have 5G small cell, like you use in city center, they have frequency 3.5 gigahertz. It's a small cell with very high. This is maybe expensive to deploy. So Orange selects these. Countryside, you can use low frequency 5G, 700 megahertz. It's the same frequency as you use for 4G. If you use, let's say, countryside, you have maybe just a few houses. You go on a low frequency 5G, which is 700 megahertz, 700 megahertz, and then you have large coverage, but not much capacity, so you can cover the areas. And 5G is also used today to cover rural areas, like you said, or villages. And there's also one thing in 5G which is new. It's called fixed wireless access. If it is too expensive to put a fiber, let's say in a village, maybe with 10 houses, people build a 5G cell with a wireless connection, like a microwave connection, to the last point. So instead of digging a fiber in some places which are difficult, people use one link connection, and then the 5G network distributes to the users the capacity. So you can go low frequency, have a large cell, not very large, but larger than the small cells, and you can with that cover rural areas. It's also used today, even when it's hard to dig a fiber through the. Beyond 5G is beyond 5G, ça veut dire après 5G. So 5G dans un étape avancée, and so this is with the 5G new core. Yeah, this will be of course easier with the beyond 5G.
This 5G will replace Wi-Fi in the future because it's more secure and faster. So when this technology will be deployed in larger range, the Wi-Fi won't be worse anymore.
Yeah, that's a very good question. So today I didn't have time to talk about this, but maybe for a next event, maybe Vincis May, we'll see. But today there's something called Wi-Fi 6. It's an advanced Wi-Fi standard because Wi-Fi also evolves. Wi-Fi is an IEEE standard, 802.11, and you have so Wi-Fi 6 is seen more as a complementing technology for 5G. So, for example, you have you are at home doing some calls on your Wi-Fi, then you want to move out. So your call is transferred, the session from the Wi-Fi network to your 5G network, for example. So 5G, for example, some places, let's say we have some customers which are car manufacturers, electrical cars. They're customers of myself, like Vodafone. So what some companies, they replaced their factory with the cité de production. They replaced the Wi-Fi communication with 5G in the factory because it's more precise and it is lower in energy. And so some places it makes sense, to replace. And some places they work better in complementing each other. So it depends on the scenario that you have. 5G will never wipe out completely Wi-Fi, but in some places it will replace it, and some places it will work in a complementary mode. This is how it will look like in the future. Yeah.
I have two more. So the set
40 or 14 or 40? Okay, 40. Okay. Let's see if we... Tell me when to stop. Okay, it's page 40. Let's see. We should keep going. Okay. This one? No, this here. Okay. Okay. Yes. Yeah. So as I said, 6G is also a specification of 3GPP. So currently there is release 17. It's like their standard. There are some specifications about 6G technology, about how to have lower delay. So there are standards. Release 17 is already coming out in 3GP. It has specification about technology. Release 18, the one which will come maybe in 1 year, it will have a lot of more specification on the technology. But when the vendors like Ericsson, Nokia, Huawei, when they will implement this technology, and how will operators like Orange, Vodafone participate in this? This will take time. So on a déjà des spécifications, but this will evolve and mature over time. And when the vendors today, there is experimental setup. So, for example, Nokia comes with Orange, and they sit there and they set up a 6G experimental network. But 6G, how it will look tomorrow, we don't know. And what will be the best production? So when you go into commercial, with real life 6G, we don't know exactly what it looks like, because specifications, they're a bit vague. You need to be more precise, and this is what they're working on. In 3GPP, the consortium of 3GP, there are all the operators there, Vodafone, Deutsche Telekom, Orange, there's, like AT&T, Verizon, all the Telecom Italia, and also the vendors, Nokia, Ericsson. So that's why there are specifications which are a bit vague. They're maturing, but when the production will really start, some people say that they expect to have a full-blown 6G between 2028 and 2030. But you will see already early commercial applications already in years before, something like maybe 2025, 26, some early applications. 5G had the same problem as 6G is having. 5G, it's a very nice technology, but there was no use case which is really, let's say, profitable for the operators. So if suppose I'm Orange or Vodafone, I want to do video surveillance, or use drones and cameras and do face recognition, detect people. If you go to a big train station like Gare, to detect faces, it is very expensive to implement. And if I, as operator, offer the service, I will not gain any money. So 5G had a lot of nice cases, but none of them were profitable. So it took a long time for companies to start implementing 5G. So 6G, until there is a really profitable business case, it will not be implemented commercially. It will take time. And this was the same reason why 5G became late. There was specification, and we just now start to see some cases coming out. So this is how it will look like probably in the future. Yeah. Yes. In labs, there's experimenting around 6G, or what will be 6G, but there is no real, let's say, it didn't yet come out in the mature form.
We will take some online question, and then I will return to the student. We have a lot of questions. The first question is from Mr. Mervins. He's a professional. He's it's a pen tester. And he asked, do you know the difference between 5G for public and 5G for railway? If MCS, I think it's for future railway mobile communication.
Okay. So if you use 5G, let's say you mean on a railway?
You can have the question on the.
Let me see where you can. It's in the platform, or?
Yes, on the platform.
Okay. Let us see. Okay. Where do you see the questions? Cancel on it. Okay. Okay. Yeah, perfect. Okay. Yeah. User. Between 5G public and 5G. Okay. Yeah. So 5G for let's say industry applications, even including, let's say, railway, it has to go through a specific kind of slice. We said that, for example, if you're a public or consumer user, you will use 5G with maybe with no slicing at all, or you will use a slice of the type EMBB, enhanced mobile broadband. If you are a railway or a rail, let's say, train using 5G, you will have other types of slices like ultra reliable low latency communication, which is much more, let's say, secure and precise slice. So the slicing that you do for applications like railway, it is different from what you do for consumer. And to ensure that you are, because in trains you have to be very reliable, you have to be very precise, you cannot risk any delays in your signal. So it will be a specific kind of slice, which is URLLC for trains. And you have to also, if a train is moving and the network is fixed, not on the train itself, because we have applications where the 5G network is on the train in each, let's say, wagon. And sometimes there is a 5G network which is communicating as the train is moving. So there are two types of, and for both of them, you need a specific kind of slice that supports that. So this difference that you mainly see there.
Okay. Thank you. Another question also from Mr. Mevent is, what do you think about IMSI capture in 5G? I think IMSI is the
Of course, international mobile server identity. Yeah, exactly. So IMSI catcher, it's, as I said, it is the usual man-in-the-middle attack kind, which we've seen before. IMSI catcher was a big problem for 5G until they now made new mechanisms to really mitigate or really to avoid that. Because IMSI catcher was, let's say, the most common kind of attack to impersonate the base station and try to capture data. And that's why they designed in 5G standalone UPIP, User Integrity Protocol, and other protocols. Also the SUCI, the Subscriber Concealed Identity Identifier.
Okay. We have another question. I think it will be also interesting for our students. It's in French.
Okay. You can ask me.
Quelles sont les opportunités pour un futur ingénieur vis-à-vis de l'évolution du 5G? C'est-à-dire un futur ingénieur, quelles sont les opportunités pour le travail?
Okay. Perfect. Yeah. So I'll answer in English, but I think that some of you are cybersecurity specialists or engineers. I think that 5G in general and security in particular, it has a lot of opportunities, because if you go today to the industry, whichever vertical you pick, if you pick a vertical like, for example, retail, you pick a vertical. Retail means like, Monoprix, all these chains that sell for the Carrefour, this retail. If you go to a vertical like automotive, Peugeot, Renault, manufacturing, industry, production, or you go to any vertical like military, any vertical, any area of industry you go to, they all are adopting 5G, and they need specialists to really understand what is the requirement of this specific campus or plant or company or vertical, and how to really design the architecture to really match this, and to have high security, scalability. So specialists with high level of skills, like some of you will be very soon. This is the kind of people that companies need to put a network and IT in place. That's why knowing these skills, architectures, understanding the next generation technology like 5G and then 6G, and knowing technical things like security, you will be very much needed by any kind of enterprise in any vertical. That's why for you have many doors open when you really master this. If you only know a specific technology and you don't know how to flexibly design it to adapt it to a different domain, it will be difficult. But if you are knowing the things in the essence, there's a lot of need for you in the industry. That's why it's a big door open, definitely, for in any vertical or any sector.
There is any question from our students? Are you sure?
Think again.
Okay. One last question. It's also in French.
Okay.
Pourquoi il y a une guerre froide entre les grandes entreprises pour avoir le contrôle sur le marché des 5G?
Okay, very good question. So, the problem is that this is also a challenge which I also want to mention. It's a very important question. So, today, politics, even in technology like networking, telco, or IT, you have politics. It means that big companies, if you take, let's say, vendors like Cisco, like Ericsson, Nokia, Huawei, they pretend to collaborate, but in reality, they each want to eat the bigger piece of the cake. And the same with operators. Like, I collaborate a lot. I'm Vodafone. I collaborate with Orange a lot, so we have a lot of nice projects. But then at some point, we are competing also. So it's very difficult to have, let's say, politically correct players. That's why when you are as a company, the policy inside the company drives players to try to capture, dominate the market. It's always like a requirement. That's why even though, for example, 3GPP, the specification, for example, for the technology of 5G and then 6G in release 15, 16, you have all vendors and operators, they together specify technology, how it should look like. So everybody is happy. It's a like consensus. But in reality, they all want ways to capture bigger market piece. That's why you cannot take out politics. It's very hard to take out politics out of the... And also the regulation authorities, les autorités régulatoires, they don't do a very good job in, let's say, improving collaboration or reducing competition. So that's why if you cannot regulate how people can compete in a healthy way, and you cannot regulate or even encourage collaboration, it will be difficult. That's why until we see a new attitude or mindset in companies to collaborate more, we will have this thing in place, unfortunately, malheureusement. But this is the reality. That's why this is how it is today. And also, the problem is that in the 5G ecosystem means end user, vendor, operator, integrator, software provider, all the stakeholders in the ecosystem, they all want to get something out of the profit. So there's a competition, there's a little bit of profit, and many hungry players. So how to find a balanced way is difficult, and the ecosystem keeps evolving. So that's why this challenge will not go away, but we need better, let's say, regulation, governance for that, and a different attitude. And until this goes away, we will keep, unfortunately, having this problem in place, which is not good for anyone. That's why having a different kind of way forward will be better for the whole community. But it's going to take, I think, time for us to get there.
Thank you very much, Dr. It was a pleasure to have you with us.
Pleasure's all mine. Happy to hear. Maybe we should mention that on May 26th,
yes,
we have also an event.
Dr. Muslim will also present on our seminar, on our symposium
on 26 May.
26 May, about software-defined networking, about virtualization, about also 5G.
Exactly, yeah.
And if you want to, if we want to contact you,
I have my email here. On the first slide, I left my email here. I don't know if you can. I don't see one on the screen. Let me. You can contact Dr. Sik and he will provide my email. But I think let me share my.
You can contact me and then I will give you the contact of.
Yeah. Yeah.